Okay, welcome, and thank you for joining us. We're in the SUSE session, tutorial 1246, Automation of Linux Performance Regression Testing and Reporting. And with that, I'm going to talk about the introduction of our speakers because this is a total collaboration effort that we're doing it. My name is Bryan Gartner. I work at SUSE on the Alliance team, and I work with hardware partners, software partners, and embedded partners for almost a decade now, and had a long tenure before that at another place. And with that, I'm handing it over to you, Bryan.
I'm Bryan Payton. I'm a software engineer in the Linux kernel group with the Superdome Flex with HPE. My primary job is to work on virtualization and containers for the Superdome Flex. On my team is Kyle Meyer also.
Hi, my name is Kyle Meyer. I'm a software engineer at Hewlett-Packard Enterprise, and I work on the Superdome Flex team.
Thank you, Bryan. Thank you, Kyle. And we'll go ahead and start going through the rest of the presentation now, and then I'm going to hand off to you for some of the slides and whatnot too, because of the collaboration that we've been working on together. So let's talk a little bit about the introduction and whatnot. We're going to have these 4 areas that we're going to cover: the introduction, the tool sets that we're using, the processes to do all this. But all of this kind of boils down into, we know that system administrators and users of systems want to be confident that when they make a change like an update, that it doesn't impact the desired performance of whatever they're running. So in the SUSE context, we do a lot of this testing, performance regression testing. But as you might guess, from a general purpose operating system like SUSE Linux Enterprise Server, we're only covering a subset of what everybody could be using it for. And also because we're more of a software company, sometimes we're hardware challenged. And that's why we have partners like Hewlett-Packard Enterprise that can now test it on bigger systems than we ever have access to. So we'll go on now, and I'll give you some more background on where this project came from and what we're doing. So the background was that we have a major joint customer that noted a performance regression when they did a patch update that included the kernel. So they asked for support. They wanted it fixed. They gave us the results. And they wanted this to be something that they could kind of preemptively do going forward so that they didn't take down their mission critical system with a performance regression. In the collaboration space, we have the SUSE support team, okay, that was able to answer that and provide that fix and give them the kernel update and thank them for finding that issue for us. But we also have our quality assurance team that does these regular performance regression. And we have a kernel performance team that is always looking at the upstream kernel and the backports that we're doing to our kernel before we ship it. So we have all that. But then, like I mentioned just previously, we have system hardware providers like Hewlett-Packard Enterprise. We're asking them, can they replicate some of this testing, not only for new things that are coming, but even for just the kernel updates that are normal maintenance updates that come out, and have them give that evaluation on that higher end system to give us results and whatnot. And it's kind of like a pre-support issue that may happen because those guys are very cognizant about performance and whatnot, and they can give us those answers. And then what we wanted to do again too with this customer is get them involved and have them test, share, review, and participate, because they may do it on a dev system that's not their production system, so that they can do it to kind of replicate and get confident, yes, this update doesn't have the performance issue, we feel good, let's apply it to the production one. But if they find a glitch or an issue, they want to be able to share that with us. And with that, let's start into some of the tool sets. So this is support config. And this is part of our support utilities thing. And this is, if you run it, this is what it looks like. What it basically does is try and gather all of the data, kind of a line in sand of what the system is like right now. So it's looking at log files and everything, gathering all this stuff up. And this is very relevant in a support aspect. But what we're also using this tool is every time we make a change in this performance regression, capture this information so we know what has changed since the last time. But you can see it creates this big tarball. And if you look at the listing of the output, it looks something like this. All of these files are collected, all this data is collected and whatnot. Okay. And then in the quality engineering perspective, we have a tool called OpenQA. And you can see from this diagram that it's basically a way to orchestrate all kinds of test cases and whatnot. And if you want to watch it in action, this is something we do in the open SUSE space for things like this. And this is what we do internally with ours as well. But you can see that we can drill down and let's look at the updates for Leap 15.3. And let's look at the last build that was done and look at all the tests that are run. And the good news is all of these are pretty much green. But if you want to look at any one of the test cases, you can see something like this. And this actually uses things like looking at the screen, looking at the output, the graphical output, and using things like OpenCV to say, here's what I expected to see. Was that true? And you notice these things are all passed. Okay. So now let's go a little bit farther because we have a support tool. We have a thing that we can run a bunch of different test cases and whatnot. But let's go through some testing scenarios and things of as we went down this path with this customer and HP as a partner, what can we do better? So we have a tool that we call Agato Regresso, which is Esperanto for performance regression. And what it does is has a flowchart of what do we want to do and how do we want to do it. And so, for instance, if you look at this flowchart, and I'll wait till it restarts again, it starts off with, we just want to run a test case, okay? And then we reboot and we can look at results, okay? But what if you want to do a kernel upgrade? Yeah, I want to repeat that cycle with a kernel upgrade and do a reboot. Oh, I want to apply all the security updates or the recommended updates. Okay, let's do that cycle. And then, it'd be really useful to remember all this data and generate a report. That's what Agato Regresso does and makes it easy for you to do. And so here's a set of test cases that are from our kernel performance team called MMTest. It's this easy to run. You can basically check it out. You can run a simple test like this, okay? And if you look at the text and whatnot, it talks about how it uses ftrace or performance testing or things like that. But you can see the actual data is showing up here. But what Agato Regresso does is become a wrapper to deploy this and any one of these test cases. And if you look in the GitHub repo and you look at the number of configs there are, the number of test cases, you'll see there are lots of them, okay? And we'll talk about this in the next steps. But this is what you can do is you can say, for me, the application that I need has these things to test, and then you can pick those things from MMTest. And once you run it within Agato Regresso, it looks like this. Okay, it generates a list of outputs and it generates a web page with the outputs and whatnot. But as you can see, there's an HTML page and it generates that, and it even highlights greens and reds, so things to maybe look at. But it also generates a graph for you across all the things that were run. And if you looked in this case, we ran it across 4 different kernel versions with the security updates, with the recommended ones. But that's how easy it is to do it with Agato Regresso. Okay. And it was very interesting when we did this with HPE and brought them in to collaborate. They suggested, maybe you should look at Phoronix Test Suite as another one. And if you look in its space, there's lots of test cases you can run there as well. And just like the MMTest, it's fairly easy to go ahead and get this installed and running. And you can see all you have to do is say, which test case do you want to run? I want to run this benchmark small PT. Okay, and then you can answer these questions and give the result and get the access to the results. But the Agato Regresso within its config file can predefine those answers for you so that you can just run a subset of all that huge list of test cases or whichever ones are relevant to you. And you can see how this one runs multiple versions, multiple iterations of it and whatnot. And again, you can look at the results of the outputs and whatnot, and you could potentially upload them, but we don't do that with the Agato Regresso. We just put them in that remote thing. And with that, I'm going to hand it over to Bryan to talk about some of the testing that they did.
All right. One of our test processes is to evaluate large virtual machines on our platform, since our platform's so large. And as an example, we were trying to extend our virtual machines past the current, at the time, 4 terabytes and 240 virtual CPUs. And lately, this is a comparison of the virtual machine and the bare metal we were actually ran for performance testing. Although we've lately just been able to run 1,472 virtual CPUs and believe that we can easily hit 48 terabytes and 1728 when we have access to a machine to test. But when we first started doing this, initially our goal was, does it boot? And then once it booted, we thought, well, can we run some vendor certification tests? And we could easily run that. But then what we wanted to look at was, how well is this virtual machine actually running? And as a comparison, we decided to compare it against the bare metal of the host it was running on. So going down those lines, as Bryan indicated, with the different products available, we wanted to align with something that gave us a good representation of the platform. And we chose the Elgato Regresso because we were also part of the customer issue. So next slide. Is that me? All right, so following the normal test suite, when we do the test runs between the bare metal and virtual, here's an example of the statistics that are provided ahead of time as far as the configuration of the test results, to compare the different sizes and if there's different kernels and operating systems that we have. And on the next slide, you can see some of the numbers that we initially got. When we first started doing the testing, the test tool that we're talking about was just getting up and started. So we weren't ready to easily see differences. And when we first started testing the virtual machines, we saw orders of magnitude difference between the bare metal and the virtual. The virtual machine was terrible. So we started getting into some performance tuning with virtual CPU pinning, huge pages, some of the recommendations. And it's still hard to see in the data, but if we go to the next slide, we can see another Pharonics output that shows a bar graph. And now, while there's differences, we're at least within an order of magnitude. We're in the same area, and this is kind of a quick look. So just recently, we converted the Pharonics output of the bare metal versus virtual we saw in the previous slide. The data from that, we were able to analyze it and post-process it into a CSV file. And as example, on the next slide, over the PM Bench test suite, we have a gross representation of the performance difference between the bare metal and the virtual, where in this case, when the virtual machine was slower, the number is higher, the percentage is higher, and when the virtual machine is better, which is hard to believe, the numbers are lower. So as you can see from this chart, that in general, the percentage difference is within a few percent, with some gross differences, both slower and faster. So next step after this is, now that we have the regression testing and now that we have the virtual machines running, we can start looking at the individual tests and see what type of tuning we can do to bring the virtual machine in line with bare metal. And again, we're able now to compare, as Bryan had said, different kernels, different configurations, and we're following the same, repeating the same path over and over and over again. And we have results we can compare across the board. Kyle has another example, so I'll pass on to Kyle.
Hi, so as mentioned, we, HP, and SUSE have a mutual customer who was concerned about possible performance regressions between SLUS 12 SP4 and SLUS 15 SP4, the release that they wanted to upgrade to. This is an example that I would like to share just to show the process of how we identify and handle potential performance regressions. Initially, when we started this project, we used 5 test cases from the Pharonics test suite. Those included small PT, T-test1, LZ bench, PM bench, and RAM speed. We added StressNG because it's a generic stress test that exercises various physical subsystems of a computer, as well as various kernel interfaces. Using Agato Regresso, we were able to quickly run all of the selected test cases on a 32-socket Superdome Flex with about 13 terabytes of memory, and what we found was rather interesting. If you take a look at the graph below, you can see that StressNG's mmap test case had a very large performance regression on SLUS 15 SP4, which is the bottom graph, when compared to SLUS 12 SP4, the top graph. And Brian, if you would like to move to the next slide. Thanks. Using Git bisect, I was able to identify that the performance regression occurred in community kernel version 5.4. So I'd opened a Bugzilla, and Mel Gorman, a kernel engineer at SUSE, determined the exact cause of the regression. The mmap test case calls madvise with different advice arguments, including madvise cold and madvise page out. Both of those had not been implemented until community kernel version 5.4, and the patch series was not pulled into SLUS until SLUS 15 SP4. Because both of those arguments had not been implemented, the system call failed, and no work was actually being done besides returning an error code, resulting in an incredibly high number of operations per second. Although the results of that individual test were incomparable, it was nice to see how quickly the issue was handled, and we were still able to record a baseline for each kernel. And now, going forward, our plan is to continue testing the latest SLUS releases on our platform for existing performance regressions, as well as the latest community kernel in order to identify performance regressions upstream. And thanks. I will hand it back to Brian.
Well, thank you, Kyle, and thank you, Bryan. This is incredible to just watch this and having doing this testing, because again, what we've done is completed the loop, just like Kyle mentioned, of submitting a Bugzilla of, hey, we found this, and because of things like Agata Regressa, which is a wrapper around Phoronix, we could hand that to our developer team and our support team, and they could replicate it and do the testing and then dig down into the things that Kyle mentioned, those kernel features that weren't enabled yet. They were deactivated. Okay. So that's how we do this. And you can see from the steps that we've done, we did this with the customer. Okay. That's how we did the fix initially. But they want to do that proactive testing and be able to automate it to make it really easy to do. So if you kind of look at what our next steps are, and one of the things is, we've given you very small examples of, hey, we did this test with these 4 kernels and security updates or whatnot, or we did compared upstream to what we're testing and things like that. But what you can do is you can run this test suite and those specific test cases across an entire release of, for instance, there's the Linux Enterprise Server. So not only for that 18 months that it's as a service pack is generally supported, but you can also add the LTSS, which is the next 3 years beyond that. And you can do across all of those. And literally it takes, because I run these on smaller VMs, hardware configured small VMs to run this just to get an idea of it. It takes an entire month to run, 20 test cases across all of those iterations, across all those kernel updates, across all the security updates, across all the recommended ones. But then we can generate those outputs like Bryan showed with the Phoronix output with the bar graph or things like that to give us the thumbs up, thumbs sideways, or thumbs down of, oh yeah, we've seen this. And it was interesting too, even when Kyle did some testing, we actually saw some things improving. And it's like, oh, cool, that's awesome. But what we're also doing now is working with that collaborative customer that we have to go and find out exactly what their usage is, what applications are they running, and then map that into specific test cases and go ahead and generalize and run it, just like we have done here before. But also to then we're working with our QA team and they are willing to say, okay, you want to run those 10 test cases? Okay, we'll add that to our open QA thing so that when we see the kernel update, even before it goes out the door, we can run that test and give that that those results and whatnot too. And for other next steps too, there are other test suites out there like LTP that we're going to add. And you might even suspect that because of our portfolio expanding all the way from Linux kernel all the way up to even things like Kubernetes, we can run things, and I've been doing this with like Helm chart, so that you can say, hey, when I had this version of Kubernetes with this distribution like K3s, RK, RK2, and using this version of the container runtime and on this OS, you can see how that matrix can be expanded and those things can be run. And that Agata Regresso is just basically a wrapper of what do you want to run when? And what it does is it does the reboots and it just automatically starts the test case again. We can do all that. And like Bryan mentioned, he did a really good job on putting together a spreadsheet. But what we would like to do too is generate a three-dimensional surface plot across that. Now we talk about a data lake of all of those things we ran it on. So my wimpy VMs, Bryan's huge VMs, Bryan or Kyle's physical monster system, and also the customer one that could be intermediate between those. Okay, we could generate that surface plot and say and give a feeling of, okay, I think we're okay, or no, there's the thing. Let's file that bug, get the support request, and of course we have the support config for every one of those runs, and we can look at before, during, and after. Just like Bryan mentions, we do an n-2, n-1, n+1, s+2 to kind of get a feel for the range of it. And of course, the three of us are starting to formulate an idea of not only do we want a 3D surface plot, but we want to do something like AI, artificial intelligence, machine learning, and deep learning models to kind of just look at that data automatically and give us that answer without us having to visually look at it. But then, kind of like you do within the classic ML space, you still want to have a human look at it and compare it, but you want to kind of get that answer generated for you. So that's what we're working on right now. And with that, thank you all for very much for joining. Thank you, Bryan. Thank you, Kyle. Again, this has been a really fun project to work on. And that customer is very enthused about what we're doing. And they're starting to work with us to start doing some of this testing as well. So now we not only have it on when we do a backport for the kernel, when the kernel update happens, when the updates are available, and in the workload context of that customer, and on those really amazing machines that HPE provides. Thank you.